Hello. So I'm going to do some of the problems from your review sheet. That way you have this to reference when you're studying. So I'm just going to go down and start and do one from every section. So I'm going to start with 1A. So for 1A, it says 2,650 milliliters of a 0.65 molar calcium phosphate solution and wants to know grams of the solute. So to do that, we're going to take our equation, which is molarity equals moles divided by liters, and plug in our values. So we have 0.65 molar equals X, we're looking for moles, and 2.65 liters. So when we solve for X, we get 1.72 moles. And now since it asks for grams, we're just going to use our molar mass and convert it. So we have 1 mole, and the molar mass of calcium phosphate is 310 grams. And that gives us 534 grams. So let's take a look at number 2. So problem number 2 is asking, first, what is the molality of a solution made by mixing equal grams of sodium chloride and water? What are the boiling and freezing points of this solution? So this is 2 questions. So first, it wants the molality of a solution. So we're looking for molality, which is moles divided by kilograms. And to find moles, I'm going to assume that there is 500, I'm going to solve it down here, 500 grams of NaCl. And I need to get moles of this. So 1 mole is 58.5 grams. Don't forget we round chlorine to 35.5. And that's going to give me 8.55 moles. So now I can plug it into this equation. So I have 8.55 moles over, and since I need to have the same mass, I'm going to do 0.5 kilograms. And when I solve that, that gives me 17.1 molality. So this is part A that it's looking for. Now, the next part is it says it wants to know the boiling point and the freezing point. So for boiling point, we have delta T equals to our molality, which we solve for. And then for water, we have 0.512, and that's going to be degrees Celsius per molality. And it's from the table or your book, and that's going to give us 8.76 degrees Celsius. Now it asks for the boiling point. So we're going to add 100 degrees Celsius because that is the boiling point of water, and we get 108.76 degrees Celsius. So that's our new boiling point. Now I'm going to skip over the freezing point because it's done just the same way. The only difference is here you're going to use the freezing point for water and K value, and that's 1.86. So number 3, I'm going to do A. And A says write formulas for A is cupric oxalate. So if we look at our ion chart, cupric is Cu2 plus, and oxalate is C2O4 2 minus. So remember, when we write the formulas, we can cross charges, and that's going to give us Cu2, C2O4, 2, and since these are both 2, we can reduce this to Cu C2O4. So this would be the formula for cupric oxalate. So now I will do one from 4. So I'm going to do 4A. And it says name these. So you're just going to look at both parts. It says MgCH3COO2. So if we look up, Mg is magnesium. And then we can look up this ion on the sheet, and it's called acetate. And that is our answer. So you're just finding the parts. And if we divide this, this is the positive ion, and that's the negative ion. 5. For problem 5, we'll do A, and it gives us calcium nitrate and ammonium hydroxide. It says write the formula for any precipitate which forms when the following solutions are mixed. So we have calcium nitrate and ammonium hydroxide. Alright, so first thing we need to do is, since it doesn't say we have to write out the whole equation, just wants to know the formula for any precipitate which could form, we can just check. So if we mix these ions, then they could double displace and we'd have calcium hydroxide, or we'd have ammonium nitrate. And if you look at your solubility chart, it tells us that when those combine, calcium and hydroxide would form, and that would give us a precipitate. So we have Ca2 plus and OH1 minus, cross our charges, and that's going to give us Ca, OH2, and that'll be a solid. So you just have to check with your solubility chart to see if when they recombine you would get something insoluble. So if you look ammonium nitrate on the chart, that would be soluble. So that wouldn't be something we'd write down. Six says write net ionic equations for these and identify any spectator ions present. So once again, we'll look at A. A, we have AgNO3 plus KBr. So if I write the complete ionic equation, which is what we need, we have Ag plus NO3 minus plus potassium plus bromine, and that's going to give us, now here's where we got to check. We got to see, will silver bromide give us a solid or potassium nitrate? So when I look at the chart, it tells me that silver bromide would give a precipitate. So we're going to write that as a molecule. So we have AgBr, and that's solid, plus spectator ions, which are the ones left, NO3 1 minus, and K plus. So identifying spectator ions, I'm just going to circle them. You do whatever you'd like. And here are the spectator ions, everything not involved in forming AgBr. Alright, 7 says just give one example of an ion which would, and we'll look at A, precipitate with bromide and with sulfide. So here you need to look at your solubility chart and look and see what would fulfill those requirements. So we need it to precipitate with bromide and with sulfide. Now when I look at that table, the first one that jumps out to me is lead 2+. There are other possibilities though. That should give you somewhere to start. 8. So we will do 8 in class, but I would like you to make a note that 8, you only need to solve for the boiling and freezing point. We're not going to do the vapor pressure. So please make note of that. There we go. Alright, number 9. How many electrons does a chromous ion and a chromic ion have? So this one is once again just looking at your common ions charges sheet. And if we look up chromium, which is what chromic comes from, and chromous, we will find that it is 2 plus 2 for the chromous, and since the atomic number is 24, we get 24 minus 2, so there's going to be 22 electrons in a chromous ion. And for the chromic, if we look, it's plus 3, so that means it loses 3. And that's going to give us 21 electrons. So 10 we will do in class. Oh, excuse me. Let's see, 11. Consider the first 2 columns on the periodic table. Answer the following questions considering the elements as ions in those 2 columns. So it says, what ions from these columns would be present in a solution if it gave no precipitate with sulfate? So if I added sulfate and nothing happened, it wants to know what ions could be in there. So if we look at our chart and we look at sulfate and we look at the ones that don't cause it to precipitate, it's actually every one except calcium, strontium, barium, and radium. So that one's purely just looking at the chart. Problem number 12. A says, how much water do you need to add to dilute 150 milliliters of 16 molar sulfuric acid down to 1.85 molar? So this is our M1V1 equals M2V2. So my starting is 16 molar. and I have 150 milliliters. Now it wants to know what volume would I end up with if I wanted a 1.85 molar solution. So 16 times 150 divided by 1.85. That gives me an X of 1297 milliliters. And now this is the final volume. It wants to know how much could I add to that 150 milliliters. So I need to subtract the 150 that I started with, and I would need to add on top of that 1,147 milliliters H2O. So you gotta read the question carefully. Let's see, 13. We have someone asked you to prepare 3.6 liters of a 5.5 molar aluminum nitrate solution. How many grams of aluminum nitrate would you need to do that? So let's take a look. So I'm going to solve for moles first. So we have molarity equals moles divided by liter. Plug it in. I have 5.5 molar. I'm looking for moles. And 3.6 liters. So that gives me 19.8 moles. Now I need to convert that to grams. 1 mole is 213 grams. So you solve for the molar mass, and that gives us 4,217 grams we would need to use. And that's for A. And I'll do B since it's directly related to that. It says after you make the solution, the person decides that 5.5 molar is too concentrated, so they tell you to dilute the 150 milliliters of it with water to make a final volume of 1.3 liters. What will the final molarity be? So we have our M1V1 equals M2V2. We're starting once again with 5.5 molar, and they want us to start with 150 milliliters, and I'm actually going to convert that into liters, equal to 1.3 liters, and then we're looking for the new molarity. So if we solve for this, we get a molarity of 0.635 molar. I'll do A. It says write equations for the following compounds to show them dissociating into ions as they dissolve in water. So we have calcium phosphate. So the first thing we need to do is write the equation. So we know calcium is 2+, and phosphate is 3-. So when we cross our charges, we get Ca, oops. So we get Ca3, PO4, 2. Now when that dissociates, it's going to dissociate back into the ions that we actually started with. So we have Ca 2+ plus PO4 3-. But now we have to balance it. So here we have 3 calcium, so we need to put a 3 there, and we have 2 phosphates. So this is your final answer. For 15, says calculate the concentration of CO2 that is bottled with a partial pressure of 5 atm above the liquid at 25 degrees Celsius. The solubility of carbon dioxide at 1 atm and 25 degrees Celsius is 3.4 times 10 to the negative second molar. So this is going to be our S1P2 equals S2P1 equation. And when we plug it in, we have 3.4 times 10 to the negative second molar for our initial concentration. And 5 atm is what it ends up at. We're looking for our second concentration, and it started at 1 atm. So when we solve for S2, we get 0.17 molar. And 16, it says, why is the change in freezing point when a 1 molar solution of potassium chloride is prepared so much more dramatic than when a 1 molar solution of sugar in water is tested? So just remember that this is a case of electrolyte versus non-electrolyte. So something like potassium chloride is an electrolyte versus sugar. So I'll do C6H12O6. This is going to break up into potassium and chlorine. So if I have 1 mole of this, then when it breaks up, I will have 1 mole of potassium and 1 mole of chlorine for an effective mole number of 2 moles. Now this, if I have 1 mole, it's not going to break up. It's just going to be individual particles of sugar, so we would still have 1 mole of particles. So our 1 mole versus our 2 moles of particles is where the difference is. 17. What mass of lead nitrate dissolves in 30 milliliters of water to make a saturated solution at 80 degrees Celsius? So the first thing I'm going to do is look at the solubility chart, and I'm going to find how many grams will dissolve at that temperature for 100 grams of water. 100 grams of water, I can get 110 grams of lead nitrate. And I'm going to set up our favorite proportions. So now if I have 30 grams of water, I am looking for how much will now dissolve. So if I cross multiply, that is going to give me an X that equals 33 grams. So 33 grams will dissolve in that much water at the specified temperature. And that is it. So hopefully you found this helpful, and we'll go over it more in class, but you can refer to this if you have any questions. Have a good night.